20 days about vector projections. I want you to imagine that you and your best friend lives on the same street as you, and you both make the following plan. You want to build a tunnel that starts somewhere along your street, so your street can be called vector B, and you want the tunnel to start somewhere between your two houses along this street. And this tunnel is going to go directly in a straight line to point A, which is your favorite place, so probably somewhere far away from school. To minimize the length of the tunnel is perpendicular to the road. So as you can see, I've started with my road, and this is vector B. It's in the direction of your house to your best friend's house. Then I know normally to get from O to A, I usually could take possibly this path OA. But remember, we want to build our tunnel that's perpendicular to B and goes directly to A. Now the aim of this tunnel is to get from your house to the point A. So notice the direction of the vectors matters. I'm going along vector B, and then I'll be going up to the tunnel. Let's call this tunnel vector W. And let's call the segment of the road between your house and the start of the tunnel U. And the main question we have for you is, how do you get from your home A via the tunnel? Well, that's pretty easy. You'd go along U and then you would go up W. Or I can write that OA is really vector U plus vector W. Notice that U and W, because U lies along B, that this is 90 degrees. This diagram shows vector projections. It shows the projection of A into two components, U and W. So whenever we have vector projection questions, they are like this when you try and find U and W. Writing it a little bit neater, we look something like this. So this diagram shows how we break down vector A into the sum of two parts. Vector A equals vector U plus vector W. Remember, U is along vector B and W is perpendicular to B. With these types of questions, we will be given A and B, but generally we need to find U. This is called the vector resolute of A. So my breakdown of vector A in the direction of vector B. This is also sometimes called the parallel component of A in the direction of B. So it's basically the vector along your base, along your road. You're also going to be asked, what is the directed length of U? So that requires two parts. One is, what is the magnitude of U? And we can find the magnitude of a vector quite easily. But also, is U along the same direction as B, or is it in the opposite direction of B? And we'll explore the second case later on. This is called the scalar resolute of A in the direction of B. The scalar resolute will be positive if U is in the same direction as B, and it will be a negative number if U is in the opposite direction of B. We're also asked to find W, and this is the vector perpendicular to B, or our tunnel, and it's the perpendicular component of A in our breakdown of A into two parts, U plus W. That vector W will always be the shortest path between your line or your vector B and the point A. And that is because W is perpendicular to that vector B. Okay, so What will actually help us in the diagram to be able to figure out what vector u is, what vector w is, and what is the length of vector u and its direction. Let's write down some things we know. Now in these questions, remember you're going to be given A and you're going to be given B. So for starters, we know that vector u plus w equals vector A. The second thing we know is that vector u lies along B. That means it must be a scalar multiple of B, right? It's either going to be shorter than B, sometimes it can be longer than B, and sometimes it can be in the opposite direction of B, but it's always going to lie along that line, B. Thirdly, we know that our vector B dotted with vector W is 0. Why? This dot product is 0 because B and W, just like U and W, are perpendicular. But we use B dot W equals 0 for ease later on. There's one more thing that we can use here. If U is, say, a constant times B, so let's call that gamma times B, then to get W, I'd have to start at the base of W, go backwards along U, and then add on A. Get from the base of W to the top of W. Therefore, I can say W equals minus U plus A, or if you want to write it differently, you could write it as vector A minus vector U. Or better still, we know that U is equal to our gamma times B, or our constant times B. So if we sub that in, we get that W is equal to vector A minus gamma B, or our constant times vector B. Okay, we've got to put all of this together. And I know it looks like a lot, but once you've done it once, this all becomes quite familiar, and we use the same process to find U, W, and the length of U all the time. Whenever you get a vector projection question, try and draw a rough sketch. Label that your U is gamma times the baseline, and that W will be A minus U, or A minus gamma B. If we can find what our constant gamma is, then we can easily find U and we can find W because we will have A and B given to us in the question. So we're going to start with the fact that B dotted with W equals 0. We're going to sub in the fact that W equals vector A minus vector U, which is gamma B. This is quite nice. Notice that we can expand this bracket. So we have B dotted with A, and then we'll do minus alpha B. Again, bring the B out the front inside. So minus alpha B dotted with B equals 0. All we have to do is rearrange this equation. On the left-hand side, I'm going to keep B dotted with A, but I'm just going to write it in alphabetical notation. So A dotted with B. If I take the minus gamma B dotted with B to the right, that will just become a positive gamma B dotted with B, and then divide both sides through by B dotted with B. In the end, we'll get that gamma equals A dot B over B dot B. Recall that B dot B is just the length of B squared. So, all in all, gamma, or our constant, is equal to A dot B over the length of B squared. You can memorize this formula to find your gamma, but I would recommend doing it from scratch at least this year, and always drawing your diagram to become familiar with the process, and just in case any proofs come up in Year 12. So now we know what gamma is, it's easy for us to find u, because remember, u is equal to gamma times vector b. So in a test, we will just say that u equals, we have our formula for gamma, a dot b over the length of b squared, and we'll also know what vector b is, so we just times this by vector b. From here, we can find the directed length of u. So we know how to find the length of u, because once we've computed u, we'll just take the length as usual, the square root of the first component squared plus the second component squared. But just notice, if our gamma is positive, then we put a positive sign, or our scalar resolute or our directed length will be positive. If our gamma is negative, just put a negative sign in front of the length of u, and that would give you your directed length or your scalar resolute of u. This indicates that u is in the opposite direction of b, but still kind of lies along the same path as b, just pointing the other way. Lastly, all you have to do next is find w. And I say all, but really it's quite a long process. So w, okay, we know that w is equal to vector a minus vector u. You're going to be given what a is in a question, and now you know what vector u is. So we can find w quite simply in the end. Just take vector a and subtract the vector u.